priority list came back and you spent all 600 credits, then you're done. You're welcome. Yeah, and the vouchers, belts, and cylinders and things, all of that will happen once kickoff starts. We'll figure out what all those are. There'll be all the rules that are either on the first website or in the actual kit of parts. And the other big piece of the kit of parts, and probably the most expensive in reality, is all of the software. There are tons of companies, because it has no real additional cost to them, want you all to use their software, get trained on it, so then eventually once you're out of college and working, you'll want your companies to eventually buy it and give them money and things like that. It makes sense. It's a very good business model. What that means for you right now is you get to use tons of really expensive software all for free. We're going to go through some of that in a second. I'll talk about what all of them are. Okay, we already talked about that. Okay, so software stuff. CAD programs, if you actually pay for them, are thousands of dollars a year. But for students, pretty much any CAD program you want, even ones not necessarily partnered with First, you can pretty much get for free if you tell them you're a high school student and you're working on a project. So SolidWorks and Autodesk Inventor are the two major ones that teams use. A lot of people ask which one's better, blah, blah, blah. It really determines on what you're doing and what you're partners with. So if you have a sponsor that uses one, things like that are important to know. We use SolidWorks. I used Inventor for like the first 8 years I was in First, so they're not all that different. Switching back and forth through them isn't all that different. They're both free, so you can install them both and play with them and figure out which one you want to use. GrabCAD is something new that they're offering free this year that's actually really cool, especially for what we do, since we're working on projects with 10, 20, 30, 40 other people all CADing robots at the same time and trying to CAD and work on the same project. What it allows you to do is actually take files from any of the CAD packages you're working on, share them with each other, and actually make sure that they're all on the same page. Everybody gets updates. All of that happens on their websites and things like that. So hopefully that'll work out. We're going to try it this year and make sure everything works. But it's free this year, too. It's a part of the donation. And then all the programming software as well. There's a large group of people work on writing all the libraries and all the code that allows it to be relatively easy to get a robot going. If you had to write all of it from scratch, it would be near impossible for anyone to do that in 6 weeks. There's just no way. But they've been working on it for a couple years now, getting all the libraries ready so that you say, I want this motor to go whatever speed, and there's a way to do that relatively simply in all the classes for several different programming languages out of the box. Okay, so before we actually can get to the game, you kind of have to know a little bit about what you're going to do with it. So real easily, what's the first thing you should do once the game's announced? Everything like that. I think I've already actually said it today. What? Start your design? That's normally not a good plan. What? Rules. Rules. All right. The manual is the most important thing in the entire build season. I'm also the lead robot inspector at the Alamo Regional, and I can't count the number of times that teams are just like, oh, but that's totally legal. I'm like, did you actually read the manual in any way where it says it's completely not legal? Because it's not. They give you the rules for a reason. Every single one of them is important. You might not think that tournament rule 86 is important, but at some point you're going to be in the tournament and someone's going to be like, you can't do that. And you're going to be like, why? Because tournament rule 86 and you didn't read it. So know what the timeout rules are, know what bumper rules are. There's a ton of things in there. We go through basically as a team and read almost every single rule together so that everyone has heard it and at least knows that it exists at some point. Some of them, little minor things can change from year to year to where if you make an assumption that, oh, that rule's always the same, it may come back to bite you later on that, oh, that was the same and it's not anymore. Every single rule in the manual is absolutely critical. First has no obligation to keep anything the same. They can literally change anything they want at any time. Not only is it important to read the rules on Kickoff, it's also important to read every single team update. So they publish 2 team updates weekly, Tuesday and Friday, right? Yeah. Tuesday and Friday, they publish team updates. Sometimes they don't have anything in them, and they'll just be like, oh, nope, we're good. That's very rare. Most of the time, they're changing something. The game design committee is relatively smart, but they're not perfect. So there's a lot of things that they go through and go, oh, wait, there's a hole in this rule that doesn't allow something else to happen. We need to fix it a little bit, tweak things. The overarching stuff, most of the time, stays the same. They're not going to change point values very often. But they will change bumper rules and all sorts of little things like that. So it's very important to have at least somebody on your team who's in charge of looking at the updates, making sure everyone else is communicated to them so that you're not going down some design path and you find out, oh no, that we could do something else or we can't do what we were trying to do, things like that. In the 2013 game that you guys saw, the pyramid climbing, there was a really big rule change where they changed the requirements for how big you could expand when you were near the pyramid, that if you weren't looking at the updates, you would never have known. It dramatically changed a lot of people's robot designs. Okay, so after you read the rules, then we're going to get into what people call designing the robot. But it's not just sitting down and going, oh, what is my robot going to do? It's a much more, should be a much more thought out process. Very similar to scientists who have the scientific method. Engineers have some engineering design process. It's not necessarily as regulated as the scientific method. There's a pretty unified version of the scientific method. Engineering design process changes a lot of times based on industry, based on individual engineers. There should be some sort of process. For the most part, it's a guide to solving the problem. There's steps that you take through every problem, and especially in FRC, when you're doing something so fast, it's very important to take these steps. Sometimes you're not necessarily saying, okay, now I'm on step 1. We're never doing really that. You're like, oh, good, step 1's done. Now I can go on to step 2. That's really not the thought. But the thought should be, okay, this is the process we go through to make sure that we're not missing anything, that we're going to get out with some sort of a clear design. Some tips by people who have been doing this for a long time: go through the process twice, once to actually design your strategy for the game, and another design a robot to actually implement it. They may seem like they're the same thing, but they are dramatically different. There are tons of ways to implement a certain strategy, but if you don't start with the right strategy first, you're not going to end up with a robot that's going to play the game very well. Because you can build the best robot in the world, but if it's designed to play Ultimate Ascent and it's in 2014, it's not going to get you any points. So like Karthik says there, Karthik is a mentor on 1114 and also an MC and runs a bunch of VEX stuff and does a bunch of other things. You must know what you want to do before you can do it. If you just start saying, oh, this robot's going to be awesome and it's going to fly and it's going to do all these things, but flying doesn't get you points, you're going to lose matches. And some of that we'll talk about in determining what your goals are. If your goals are just to make a really cool robot and you don't care if you don't win a match ever, have fun, build a really cool robot, don't win matches, that's up to you. Most people like winning matches. I like winning matches, so that's normally one of our design goals. Okay. Seems like there's a lot of steps. Again, we're never actually like, man, I wish I was on step 7, but now we're only on step 6. We can't quite get there. This is all happening, if I unplug VGA cable, nothing works very well. Okay, we're going to get it back up. So all of those steps are happening kind of at the same time. Some of the time you're following through on, you might be designing the drive portion of your robot, but then you're going later on. Come on, come back. That's 2. Right, so you might be designing the drive instead of at one step, and you'll be on your arm or your shooter on another step. You may have subgroups working at different times. Okay. This is sad, this never happens. All right. It's coming back. It's trying. Anybody have any jokes? Anything you want to share while we have this nice break? Yeah. You got open mic time. Anybody perform a song, slam poetry, whatever? Have fun. Yes.
On the Wikipedia page for pool noodles, under other uses, it was first robotics competition.
We got put on pool noodles? Yeah. Now we've hit the big time. All right. We're on the pool noodle Wikipedia page now.
Guys, how many accountants does it take to screw in a light bulb?
Oh, God.
3. 1 to steal the light bulb, 1 to screw it in, and 1 to fudge the numbers so no one will ever know.
You just actually told a joke. Didn't actually. It was shocking. Didn't expect anyone to tell me a joke. All right, here we go. Maybe? There we go. Haha! Didn't even take that long. Took about 1 joke's worth of time. All right. All right. Now we're gonna securely. All right, we're back. Okay. We are back up and running. All right, so engineering design process. A lot of people are going to have different ones. They're not all going to look like this. I actually added step 0 to this slide this morning when I remembered I wanted to add it a long time ago. And we'll talk about why and why that's important. So basically, going through this, we'll have tons of different subsystems. You'll have different robots. You'll have different strategies, whatever you're doing. The idea is you get some way to figure out methodically how you're going to design the robot and what you're going to actually build. Okay, so the step 0 that we talked about, that I added, is basically figuring out what your resources are. If you go through the design process and you end up on a design that you can't build,
you said iterate as many times as you need. How many times do you guys typically iterate?
If I counted, I would be sad. So I mean, it's pretty constant. I mean, we were making, that robot competed at 8 events. We were still rebuilding parts of it right before Remix a couple weeks ago. So we just kept going. And by far, it was not perfect by any means. And nobody's robot is, and they keep building them throughout the year. Okay, so step 0, evaluate your resources. So if you come out with if you sit through the whole design process and you end up getting to a robot that you can't build, it doesn't help you. Right? Like it would be great if you could build it, if you could figure it out. But if you don't have the resources to do it, like there are gonna be limits, right? You have to know what those limits are, what your constraints are as a team before you even get into what's the best strategy, things like that. There's gonna be constraints on other things about the rules and things like that that actually constrain the robot itself. But the constraints you guys have as a team are very important. It's going to be very different for a team that has nothing but veterans. They've all been doing it for a long time. They have a huge mentor base. They have a giant shop. They're going to be able to build a much different robot than a team that's just starting out, never seen an FRC game before, and that's just the way it is. So it's important to know all of those different things. So if materials, parts you have on hand, all things like that, budget, what events you're attending can change your design process. I know we look at that very specifically. If we're going to a week 1 event, our design changes because it pushes up our whole schedule. We know that all the programming has to be done in 6 weeks. We don't have time to program after we bag the robot. We don't have any of that stuff. All of it has to get done. Our schedule gets pushed up. If we're only attending a late week 6 event, we might build something a little crazier. We have time afterwards to play around and figure out ways to make things work. How often you meet, how much time a robot's going to take to build, all of those things can play into your design and should be really thought about right now when you have time to think about it. Right now being like, not right now, but before kickoff. Okay, so step 1 of the process is then actually figuring out what the problem actually is. This is probably the simplest step. For most people, they think it's the simplest step. They'll often be like, oh, you know, it's hanging tubes or shooting frisbees or whatever. That's somewhat of the problem. But again, it goes back to what you guys decide as a team what your goals are. If your goals are to do very well at an event, it might be score points, right? If your goals are to win a regional, you'll have different things that you need to do for your strategy. If your goal is to win the FRC championship, you'll have different things to do for your strategy. So figuring out back to what your goals are, what your team wants to do. If your goals as a team are to have your students learn a lot of different cool technologies, you'll build a different robot than someone who just wants to win. So again, that's a team decision. Teams do it different ways, and you get different results because of it. But today, our goal is going to be the 2007 game that FRC played called Rack and Roll. So this is for a while ago, but you can see kind of what's changed and what hasn't in FRC. So this is the game animation from Rack and Roll. Okay. So you can see that was it's very different from the games we played the last couple years. Clearly there was no throwing things very much in that one. Not launching objects like we were in the last couple of years. Okay. All right, so at your table you should have copies of the game rules, as well as one-page descriptions of the rules as well. So you can go through a little bit more in detail, but we're going to talk about most of them up here in general as well. But as you're going throughout the day, feel free to look at what the rules are, because one of the important things is to be able to actually read what the rules are and the way First gives them, and interpret the actual First rules. Okay. And there's probably spares around. I don't think we're done. All right, everybody, if we can have your attention back up here real fast. Okay, so we're going to go through some of the basic rules as a group. Okay, somebody want to, after you're going through it, somebody want to explain how the scoring is calculated? Anybody? Didn't get that far? All right, so this is probably one of the more important parts of this game. And it was a little bit weird. We haven't had a scoring system this complicated in a while, and they probably won't go back to it, because as fans, you were kind of like, who's winning? I don't know. So anytime you have a row, you get 2 to the n points. So a row of 2 gets 2 to the 2, you get 4 points, and it goes up from there. You learned this 2 to the powers really, really well that year. You knew them all in your head. We don't have to do that, but in general, the longer rows you're getting, the better. So if you're playing smart, you want to make sure you're splitting up other teams' large rows, and you're getting as long of rows as you can in the entire rack. Yep.
In the animation, it showed that we could put spoilers on a rack. If we put a spoiler, can we put then our own?
No. Nope. If you go through the rules as you get farther along, one of the rules specifically is that a rack can only have 2 tubes on it at any one time. And the spoilers can be moved, but so you can unscore. But once a red or blue tube is on a rack, it is red or blue or nothing. That's the only options.
Let's just say there's a red tube on the rack. Can you put a blue tube on the rack as well?
If you do, it's still red. It doesn't give you any points, so have fun. But it accomplishes nothing. Okay. Oh, questions? Yep. No, if you take the spoiler off, it comes valid again. So that was the whole point of the spoiler. So if you entered a spoiler and you hung it on a red tube, a red team could come over, grab it, hang it on a blue tube, and now the blue would be spoiled and the red would be good again. Okay, so the different types of tubes in the game, just real fast so everyone gets an idea. Keepers were only used in Auton. If you had a keeper on the rack, it couldn't be spoiled. You couldn't put the black tube over it. So that was the point of those. They were very tricky to do back then. Autonomous was way harder in 2007 than it is today. It's still not easy by any means, but very few teams were hanging keepers in 2007, just because of where we were in technology. It was 2 control systems ago. Like, it was a while. Ringers are the general game piece. There's actually one sitting up there folded, so we went through a lot to actually have a ringer because we weren't a team in 2007, so we didn't have any of the game pieces. That one was actually sent to me by a friend in New York, but I didn't realize he sent me one that had nothing but holes all in it, so we can't actually inflate it. Or we tried really hard, but it did not really work. The triangle is from a different game that we're going to talk about a little bit later. The circle there just doesn't inflate. But you get some sense of idea of how big we're talking. If you can't do relative to the screen, that's about how big they actually are. In real life. The spoilers are black, they're all the same size. And one of the more important parts of this game is you can only possess one at a time. So you can't just stack up a bunch in your robot and hang them, things like that. You have to actually only possess one of any type of game piece at all. Okay. Penalties, and this page we're talking about things that pretty much don't change. These are things that will never be legal in first in almost any game. I can't say never because the GDC could decide, oh, this year we're just tipping everybody, but I highly doubt it. So most of the time, no tipping, no pinning longer than 5 to 6 seconds. You'll have refs count it out. If you competed in the off-season events, you know a lot of these. No entangling or grabbing other robots. We're not damaging other people intentionally, and you can't leave parts behind. The simple analogy is, we're the NFL, you're allowed to hit people and tackle, but you're not allowed to kick them in the face, right? We're not UFC. Question? I cleared up?
Yeah, this is going back to the scoring.
Oh, okay.
Could we have put a spoiler on a rack that had no tooth and then maybe take it off and put a tooth on?
Any rack that has a spoiler on it doesn't count.
What happens if you put a spoiler on a keeper?
Nothing. You can't. Yeah, the spoiler is wasted. It can't do it. The keeper keeps. Yeah. Okay, so penalties in this game, in general penalties, are all 10 points each for the most part. You take a 10-point hit for doing any of these things. So if you were to de-score a keeper or a ringer, so if you were to grab another team's object off the rack and pull it off, that's a 10-point penalty. Possessing multiple game pieces was a really common one that year. The end game, where you saw that they were lifting up other robots, if your opponent, if you were in their home zone at the end, that was a penalty. Again, any way that you were using angled or sloped surfaces, basically they knew they were providing a ramp game. You saw in the video that the robot made a ramp. They didn't want you to use those in any sort of defensive mechanism to tip people or anything like that. Those were used only to allow you to lift up other robots, and that was it. Okay. I didn't make a slide on the end game. Anybody want to explain go over the end game rules? It should be on the one-page description. Do some teamwork. Yeah, Phil.
Especially for the people who are newer, they should be aware that unless the rules explicitly prohibit it, it's allowed.
Yes, that is, and most of the time that is true, but a lot of times one of the things we haven't hit on is the Q&A. So what Phil's point was that if the rules don't say you can't, most of the time you can, but there's also a Q&A that if it's pretty blatant and you think there's some issue with the rules or something where you think they have like a glaring hole in the game design that you're going to take advantage of, it's very reasonable to ask on the Q&A, an interpretation of a rule, ask for clarification, those types of things. They're notorious for giving not necessarily the most clear answers all the time, but at least you did your due diligence in figuring out whether something was legal. And that may not always still work. There's a very well-known case in 2012 with a team very close, 118 from Clear Lake. They built a mechanism that they thought was legal to basically hang off the side of the bridge that year. You had to balance a bridge. It went all the way to the morning of their first event. They were about to play. They still thought it was legal on practice day of their regional until First told them it was illegal the Friday of their event. So First can do things like that if you're trying to push the boundaries of the rules. It doesn't happen all the time, but there's lots of teams who have also gone the other way, pushed the boundary of the rules and gotten away with it and had great robots. So there's some risk-reward factor if you're going to be somewhat outside the intent of the rules, right? This game, it's very clear that you're supposed to be hanging inner tubes and you're supposed to have robots that can lift other robots. If you're doing something else that's a little bit weird to score points, you may end up getting it ruled illegal or something like that. Okay, somebody have the endgame rules?
I got 'em.
Sure.
The final 15 seconds of the teleoperated period is called the end game. During this period, no robot may be in an opposing alliance home zone. The intent of this period is to permit alliances to attempt to score bonus points without undue interference. An audio signal will sound 5 seconds before the start of the endgame period and again at the start of the endgame period.
Okay, so what are the point values?
You get 30 bonus points if each robot is put above the ground, and each robot that's 4 to 11.9 inches above the ground gets 50 bonus points.
Okay, so you're getting a pretty decent bonus score, either 15 or 30 points, depending on how high you lift another robot. If you manage to get 3 robots lifted off the ground, that'd be really impressive, and I don't know how anybody would pull that one off. theory, you know, you could do it. Okay.
Can you hang on any of the other parts?
No. And you have to be in your home zone, and you can't grab the field. You can pretty much never grab the field, unless like the pyramid and you're intended to climb on it from 2013. Okay, so this is the basic layout of the FRC field. These don't change too often. Most likely won't change anytime in the near future. There's a ton of investment now in the fields. In 2003, there were probably only 6 or 7 fields in existence. We're probably pushing 35, 40, 50 fields in existence now, plus all the ones that Andy Mark's making that teams own. But FRC and the districts and a bunch of other people own field perimeters now, which is basically just the metal part. So the dimensions are pretty much, they can do some things with them, but they can't do a lot. Unless they want to make so everybody's rebuying, you know, $30,000 worth of stuff, and that's normally not going to happen too often. Alliance stations, so where the humans actually drive, are at the ends of the fields. People have been to the off seasons, you know that pretty easily. Those stay roughly the same. Here's the overhead view. This is a very, very flat field. There was no field obstacles. There was just a giant rack in the middle. That determines a lot of your things about your drivetrain. If you do have to climb over anything, what you're driving on, surface, all of that kind of stuff goes into robot design. Okay. You did have to drive up other ramps, but it was, I mean, it was a flat field. Depending on if you were a ramp bot, you didn't have to drive up other ramps potentially. But we'll get into that. That has to go into your design as well. So I don't have a video for it this year because they didn't do it during Kickoff. But they used to actually, part of Kickoff every year, they would have humans play the game. And it's one of the things we still do on Kickoff with our team. We'll go find a gym, whatever. We'll get things that kind of look like field objects, whatever we have. And we'll attempt to play the game as if we were robots. We'll define, like, Mary, you're a bot that can only push a ball, whatever. Jacob, you're a bot that can throw balls through the goal, whatever. Yeah, we do. If you want to go on our YouTube page, there's a video of us doing it from last year. It's hilarious. It's just people like crawling around on a gym floor. What?
What is your YouTube?
YouTube.com/Spectrum3847. I didn't really mean right now, but I mean, could. But in general, it's a good idea to just get some feel for how the robots are going to have to interact and some feel of a little bit about timing, what they're going to have to do. You'll learn a little bit about strategies, that kind of stuff. And it gives a lot of people who are visual, it gives you a really good visual way to see what the robots are going to have to do. It works better with some games than others. Last year was a pretty good game for it. 2013 probably wasn't the best. You're just throwing frisbees around.
Another thing is like just play